If you want, you can go through it. So many subjects coming together, they are becoming one broader topic like data science. Before this word is coined, data science, usually people were calling it as statistical science or statistics. Observing the data for so long, you can do two things. You can analyze what's happened. The second thing, you can also analyze what may happen in future if such situations arise, or if any close situation to the previous situation which you observed comes, then what may be the outcome for that? Something like that. So that is usually it's a data collection, data analysis, all those things, even data prediction based on regression. They were not calling prediction, they were calling regression. And simple classification like that, or clustering. All those things were very famous words in statistics. But when these computers have become popular, then this data science word has become popular slowly. When these applications are, computer applications are put into the statistics. In the whole science, if you see, initially the mechanical science enabled humans to do more work through machines. So earlier, one person was able to dig something. Now, if he gets a proclaimer, he can dig 1,000 times more than what he can do in a day. Means it enhanced their physical capabilities. If he can travel 100 or 10 kilometers or 50 kilometers a day, after this mechanical things, this car or train, whatever that has come, they made him to travel more than 50 kilometers, means maybe 10 times more than what, or 100 times more than what, through airplanes. So they are able to enable their physical capabilities, extend or enlarge their capabilities to do the more things. That is the innovation mechanical engineering brought into this. Similarly, medical science brought people to live more number of years or longer life. So it enabled not only that longer life, it also enabled them to have a healthy life. Similarly, when these computers have become popular and people realized their potential, how to use them, they are able to enlarge or extend their mental capabilities now. How much they were doing with their mind earlier, the same thing can be done by using these computers 100 times more than that. Simple thing, earlier accountants were taking the data, the whole day transactions, and they are summarizing at the end of the day how many sales happened, what is average sale, what is the maximum sale transaction, what is the minimum scale transaction, all those things. But he was taking the whole time, the whole day, and also the help from others, assistants, to put together all those data. Now computers have come, you don't need an account. The transaction, if it is done by online, then it will summarize in a second. Means he can summarize for, same person can summarize for many accounts the summary. So it enabled his capability to do earlier for only one stream or one company. Now he can do for many companies. Similarly, when we were writing some algorithm for prediction, then one person can do lots of work, but can design an algorithm for only one physical phenomena. But when these computers arrived, then he can do, or he can reuse the same thing, and he can do many jobs at a time. Means it is the computers have enabled people to enlarge or extend mental capabilities. So we don't need to worry that they are going to replace humans. No, computers can never replace humans. Like as I told you, mechanical and health sciences, how they enabled people to do more things physically, live happily and longer life. Similarly, these computers also will help to do the more things what we can do with our mind 1,000 times more than that. So they are not going to replace us. They are actually enlarging our capabilities. So that is first point which we should understand. Whatever computer does, somebody has to still program it. Earlier days, this machine learning, data science, definitions were something given vaguely without explicitly programming. If computer can learn to solve a problem, that is called machine learning. But later on, they changed it. Unless you program it, you may not be programming for one problem. You are programming in a general setup now. That general setup, from that general setup, the program itself, we will write so that the program itself adjusts all the parameters what it uses so that it is suitable for the different situations or different data sets. So coming back to the data science, what is data science? Data science, as I told you, it's a many subjects coming together, it has become data science. The first thing is the statistics. Second thing is the mathematics, because we need optimization techniques, how to get that optimization point. So that is mostly we use mathematical technique. Then intensive computer programming, because we should be able to write, gather the data. You know that in introduction to data science, we discussed it large this. So you also know that it involves lots of programming. So intensive programming is used is also important for this. Then some experimental sciences. So once we do the algorithm, then how to evaluate that, all those things. Then finally, the business acumen. Unless we understand the business, we cannot help them by using data science techniques. So putting all together, it has become a data science. So if you are doing one specialization, means you are becoming almost, you are learning all these things. Then only you become a good data scientist. So wherever you feel you have gap to understand, you can go back and refer. Statistics, suppose, you can see that Khan Academy, what is this term, then where it is used, how it is computed. If you can understand better, then you will have more confidence when you are applying those algorithms in a real life situation. So I suggest all of you, whenever you feel there is some gap, please try to fill that vacuum by reading different resources. After reading resources, if you have still doubts, you can approach me. Then we can discuss here 11 to 12:30 I will be available. That is the second thing. And third thing, coming to this specialization, it is a large field, a very big field. Each small field or each subsection in this field may become a specialization. I discussed it with somebody, topic modeling, that itself can become a specialization. Or any supervised learning, machine learning, deep learning, many things will come here. Or big data, how to handle data, data processing, data visualization, how to visualize. So there are many topics will come into this. Each one may become a specialization. Not only that, application-oriented specializations also become popular now. Data science for health science. If people are interested, they can spend whole time to understand what are they. As I told you, business acumen, if you don't have, then your data science is not useful. So you should also have to understand what is this business, how we can use data science application to enhance that business. So this data science has become many things now. You can see that they will ask immediately, what domain you have experience? Healthcare or health domain? Or stocks investment, or revenue optimization, whatever that they call, or something like automated cars, all those things, mechanical field. There are many applications of data science. Even testing level also, there are many applications for data science to reduce the false products to go out of the company. So finance domain as in a broad sense, not only for stocks. Then it's a genome sequencing, all those things. It's not exactly a health field, but biological sciences. You can name many. See, whatever field you take now, even in governmental and elections, how to win also, they're using political field and social field, e-commerce field. Any field you take now, there are applications. So each field has its own problems. We need to understand that business, how it runs, how we can use this data science to achieve goals in that business or enhance profits in that business. So we try to give you a basic understanding now, but you should spend enough time to understand these domains. Data science is not learning some algorithms. Data science is understanding the business. Data science is understanding how do we apply these algorithms to that business to optimize their profits. So our concentration is as many examples as we see how data science is applied. We are not going to spend time to understand how these algorithms were developed, the mathematics behind that, the statistics behind that. Those things we will superficially, or it's high level we try to understand, but because of the lack of time, we don't go into the details of deriving each formula, those things. But as much as we require to understand a basic feature, why, how it works, that much only we will spend time. We are not going to derive or write new algorithms in this course, at least these 4 months. We are the specialization. We are going to see already existing algorithms, how we can use and use them to enhance businesses or enhance some of the parameters, maybe social parameters, whatever that it's, predictions, those things. So our focus is mostly on how do we apply data science for different fields and achieve the goals, what is expected in those fields. So that is the thing. But I assure you that whatever is required, we can still go through those mathematical statistical understanding, but you should be proactive because that is more intensive study you require. As all of you know that I come from a mathematics background, so I also love to discuss, but we shouldn't sidetrack too much into the getting into the maths and statistics, and at the end of the 4 months, not know how to use these applications to the real life situations. That is not a great situation because we are not going to create, researchers or scientists in these 4 months. We are mostly an industry ready students, so that they can immediately apply and come to the production in that company. So that is the focus. But however, if somebody is interested, we can still discuss those things, provided you go through those things and you write down, this is understandable, this is not understandable, let's discuss it. That also can be done one-on-one also. Some people may not be having that much of interest to know that mathematics. So it's, as I told you, it's a vast field and a large subject. Different people may have different interests. So I leave it for you to see how deep you want to go at that level. And third thing, we are going to evaluate this whole applied machine learning. We call applied machine learning means we will focus on applications of machine learning, not focus on how machine learning algorithms can be written, what is the math stats behind that. We will take different situations and we'll try to build that. So there is a project in this applied machine learning course. That project is for the entire course. As we progress, we develop, we understand, and we use some data sets to apply those algorithms. And we will also learn how to analyze those algorithms, how to measure the performance of outcome of that algorithm, those things. So as we progress, I want all of you to have a machine learning toolbox. So toolbox is nothing but your algorithms will become tools, but they are not ready to use in any platform now. Still, you need programmers to write some programs to use them. So you will build a machine learning toolbox, means you will put together all the algorithms. You understand how each algorithm should be applied and if a data set is given. So if a data set is given, immediately you should be able to tell this data set is good enough to apply this algorithm. then I will apply this algorithm. Not one algorithm, there may be many algorithms you can apply and get the results. Then you should be able to say that this algorithm performs better on this data set to get this goal or to solve this problem. Then what basis you can do that? Then you may need to understand the parameters of the algorithms involved. How do you tune those parameters? All those things should be automated in your toolbox. So finally, it should come something like non-programmer also can be able to use your toolbox. So for that, let's say before getting into the real machine learning, I'll give you an example that if you are successful in your toolbox building, then I'll show you a small example how my students, I asked some of you to work in topic modeling, but unfortunately, most of you were not interested, but I worked with some JNTU students and tech students there. Then we built a toolbox, which I want to present. That is what my expectation from your machine learning toolbox. So I'll show you that this topic modeling can be used by non-programmer. I'll share my screen so that all of you can see. So this will set the expectations of project.
Class into
Please mute if you're not speaking to the class. Go back. So this run.py, this is the script which they wrote. So it is something like some 1,200 lines of code. They, as I told you, finally, there may be lots of work to be done at back end, but you can appreciate once you see that no programming is required to use this now, this topic modeling toolbox. I'll run this and I'll show you that this only one file we have. If you run that file here, then it will give a in our local server address. So you can open by using you can see my screen, right?
Yes, sir.
Yes, sir.
So now I open a browser. Then you can see this, see what is topic modeling we are explaining here. Topic modeling is a machine learning technique to identify the patterns in text documents and discovering the similar documents based on a topic. There are 5 different algorithms are there. These are the tools for us. then 5 different algorithms will become 12 or 13 different variations when you do other techniques combining with this. So we are saying that there are 5. So even for a layman, we are trying to explain. This is not done with one algorithm. We have 5 different algorithms are there. Then simply they can upload a file. Of course, we need to mention what should be there in that file. We are mentioning here. Of course, it's because of the time shortage, we haven't done everything, but we are writing here. The column with the text document should have a column name as text. So in that column, different documents should be put in the same cell. Means first cell will be one document, second cell will be second document, third cell will be third document. So this is related to the different documents. How do you find out different topics are there in that? It's a segregate based on topics, those documents. So if they have that file, simply they can upload this file here. They can go to real docs and projects. Then I have a file here, example.csv. I'll show you that what is that. Then if you want how many topics to be divided, of course, this also can be parameterized later, so that optimal topics, so that people will realize exactly there are 20 topics or 13 topics, whatever. That work is to be done by comparing that how good if you divide into 20, if you divide into 15, how good. We'll also discuss in machine learning that topic. Now, if you submitted a file here and you are trying to get your topics from that data set, and we'll see that what it does. So it has to do so many algorithms backend. Then it has computed all those algorithms on the data set. You can see that it is giving a little bit analysis here. You uploaded a file with 687 documents, that is 13 rows. But finally, after updation, we used only 5 columns. Of course, 687 documents, 687 rows, 5 columns. The analysis is done with performance results. So we run on the same data set for topic modeling, almost 12 models. The evaluation report after running all 12 models on the data set. So we are giving a report this, how to perform. We know that there are different scores, which model is good. So we have given here 3 scores: Silhouette score, Kalinske score, Davis score, so that people can understand that which model is giving good result. So when you get the topics, then there is a performance metric, not one, there are different types of performance metrics, but we are giving importance for Silhouette score. So according to this Silhouette score is between 0 and 1. According to this, LSA with spectral is performing very well, and some of them are not doing great. So only 5, but 5 have become now 12 algorithms because of the combination of other algorithms with those 5. So these algorithms, LSA with spectral, word-to-wake, all those things. So basically 5 different techniques are there. Those techniques, you need to use different parameters. Then people may get doubt that what is the guarantee that you use the correct parameters? If I try on my own, I may get good results than you, because this is all you are providing some parameters. Then I want to see that your analysis, how you selected, or if I want to try by changing parameters, how can I do? Then I clicked one algorithm here for this demo purpose. Then we will see that what parameters we used for that algorithm. Then we will also see that when you use those parameters, or when I tried those parameters, how I see the trends of performance of that algorithm that I will present now. So again, it takes some time. This algorithm is a complex algorithm, word embeddings. This almost uses all of the machine learning algorithms. In fact, deep learning algorithms, clustering algorithms, machine learning algorithms, latest techniques of word embeddings into topics, those things. So we need to do a little bit optimization still, that is pending, but so largely the work is done. So it may take a little bit time. Be patient. So that you should see now all machine learning algorithms should be there in your server. Whenever you give a data set for a classification problem, it should run all the algorithms. You should give a report like this, which algorithm is performing. Now, if people want to play with parameters of each algorithm, first you should give idea that it's how you are observing those parameters when you change, whether you are improving the performance or not improving the performance. Those things will come now. Yeah. So one algorithm I am trying to explain in this demo. So for word-to-vec clustering, there are three parameters basically are important. So one is the size, dimensionality of the word vectors. So in this algorithm, the entire corpus or documents are converted into vectors. So not exactly the documents, but of course the doctor vector is also there. First, we will take each word and that we will convert into vector. So we will convert into what dimension of vector. You can go from 0 to any number. We are giving here, when you are taking the dimension of that word embedding or word vector, when you are converting words to vectors, so this distortion should be less, one of the performance of the data set when you apply word embeddings. So you can see that it's if you don't word embedding, or if you do with only one dimension, 2 dimensions, you have lots of distortion. But drastically it fall into almost half distortion if you are something like 50, 60 dimension. As you increase vector dimension, then you can see that it's drastically, but sometime it is upping up, but largely it is coming down. But after 250, not much change is there. But of course, 400, you can, of course, if you increase, then it may come, it's other things. But this give an idea for the user. Okay, if you want what dimension you want to put or what size you want to put, let him select that size by looking at this. Similarly, each word, when you convert, the word meaning will not come just with that word only. The context of the word will come based on previous words and afterwards. I give famous example for many times. Let's say book, the book meaning you will not come to know that it's in what context it is used. You should know that the before and after, as I said, I have a very good book to read machine learning. Their book meaning is different. I need to make a complaint to book this person for his criminal act. There the book meaning is, means the book meaning is not coming with that word itself. What words it is surrounded by. Then this window tells that it's saying whether you need to take 2 words before, after, 2 words later, or 3 words before, 3 words later. That including that word we call in word embeddings, it is a window. So what window you take, then we are giving again. If you take a window size of 2, then obvious distortion 3, 4. This gives a largely an idea for us that it's saying as you are increasing the window size up to 3, it is largely useful. After 4, it is little bit useful, but after 5, very little. But after 5, you can see that there is no meaning of increasing the window, at least for that data set. This is all related to each data set. What you different data sets may behave differently. So now one more parameter is there that that not much is there, which we can show visually, but minimum count means what words you consider for topic modeling. Very rare words, if you want to ignore, you can ignore. If you say that minimum count is 3, means at least 3 times that word should appear in all the documents, something like that. So if you reduce the minimum count, then you can get more words. If you increase the minimum count, then you are removing the rare words. Now, the user can experiment with this. Okay, now we gave some idea what parameters also we mentioned for that thing. Now, if I want, by looking at 400 is performing good for me here, 300, yeah, 400 is performing good for me. I'll select the 400 for the user advantage we are giving this. Window size I have seen 5 is good from that, or we are not forcing them to use 5 or whatever. We are giving some trends, what we observed. Then minimum count, I will say 5. Then I do word-to-vec analysis. Now again, I will perform the same algorithm. I gave some results. Now I am asking user, If they want to change the parameters, if they want to experiment, let them experiment. For that experiment also, we are giving some clues, how you do, how these parameters will help in getting good results. So again, it takes some time. This particular algorithm is a complex algorithm. Now, the again summary, we are getting number of clusters 20, the dimension size which we selected 400, the window size which we selected 5, the minimum count is 5. Then with word2vec, 4 algorithms, and when clustering comes, 2 different types of clustering is there, k-means and hierarchical. Putting together 8 algorithms we run on that data set by using these parameters. Now we are giving the complete results that it's when you are performing word2vec with bigram, k-means labels, then you got 20 clusters, means 20 different groups of those documents. Then you can see that in each cluster, how many documents are falling. The highest cluster or the big cluster is having 77, lowest is having 1 document itself. Then the composition. Then how do you analyze, or how do you get that what topic is there? Then most frequent words in each cluster we will take. That should give some idea for us. Then we are also giving what are the words very frequent in those clusters or in those topics. So for 20 clusters, we'll give the including their frequencies. Mayonnaise is coming 51 times in that particular cluster. Employee. There is I'm not getting into the more topic modeling thing, but my focus is if you have a toolbox, you should remove the data scientist between the algorithm and the client. Client should be able to use all your data science algorithms or machine learning algorithms without writing a single programming line. So all 8 you got now. Then finally, we are also giving internal evaluation. We are also showing that how these documents are clustered now. The small things are documents, so the big circles are cluster centers now. You can see that there were only 1 or 2 documents in some clusters. They are these, they are densely. So largely it looks like a linear, they are falling on a linear line, a little bit above and down. You got these clusters, so you are able to separate them. The separation also, you can see how good separation you are getting. In the middle, you can see that not a great separation, but at least you are able to remove the anomaly type of things. But in the middle, we may need to still work. This algorithm may not be giving that great clustering here. But still, it's in a linear scale, you can see that it's in 1 dimension, they are varying much. Because of that dimension, from left to right, you see different groups, you are able to put them. Then internal evaluation, again, for these 8 algorithms, we are giving the scores. But we got something like 0.54. By changing parameters, they are also getting now 0.55 also. A little bit improvement they got because of their experimentation. Then there is another evaluation when you apply several algorithms, then you can also see that how good your data, counting pair evaluations that is called. Then you can see that whether data is really having different topics or not to divide, or we are dividing artificially for that, these techniques will help. So this whole thing, summary we have given, then they can download the whole data, what this algorithm performed, whatever the documents they give, then we are putting them into different clusters and we are handing over them. So you can see that it's each document in each of the clustering techniques. We have 12 clustering techniques, but here 8 we got later. For those 8, this particular document is falling into 4. So all 4 will come into 1 cluster, then 15s will come in 15 clusters to 12. So now they got groups now. Of course, this still you can make different folders, and from the folder you can ask them to download those things. See, that work is there. But all these things to be automated. The aim is we should remove the data scientist between the algorithm and the toolbox, the client. So whenever we get into the, I'll stop this sharing. So whenever we get into the company, you should be able to use your toolbox, machine learning toolbox, at least at the first instance. If somebody asks that, I have this data set, I have something like pre-processing is also done, suppose. Then I have these are the explanatory variables. This is the response variable. Can you tell me that see which algorithm works better than on this? One way is do the all mathematical statistical analysis and theoretically find out which algorithm works. Other way is it's run all the algorithms, whichever works better, you give that algorithm. So we are taking the second approach because most of the algorithms still in machine learning are heuristic. There is no scientific basis that only this algorithm works better or that algorithm works better. Of course, some reasoning is there, but not the final reasoning is there in machine learning for many of the algorithms. So earlier, when computing power was costly or computing resources were costly, people were not afford to run several algorithms because it takes so much of computing resources. So that's why they were deciding on basis of some heuristic things. Okay, this may work in this situation well, so I will apply that and see whether I'm getting good result. So now we don't need to worry about the computing resources. They have become affordable now. You can, when we started work, you might have worked with 256 MB RAM machines, but let's say you have now 16 GB machine RAMs with you. So that computing resource has become affordable. So you can run all the algorithms. Then you can ask the user also to experiment which algorithm works better for their problem. So that is the project which I designed for this course. So you may learn, let's say, 5-6 algorithms for supervised learning, 5-6 algorithms for unsupervised learning, and some recommendation systems, those things are there. But we will concentrate in this course mostly on supervised learning, because some of the unsupervised learning algorithms we will study again back in data mining. At that time, you improve or increase your toolbox size, means you will add more algorithms there. So my final expectation is, as I gave you a demo, you should bring up that toolbox for me. If data set is there, that data set, I should simply upload and be able to play with that toolbox to get an optimum result without writing a code. So for this, you may need to team up with the people who are good with the little bit. Initially, we focus on CLI interface, command line interface. Later on, if you really build, like as I told you, it's a Flask is easy, which I use it here, Flask to build that web interface or anything. So you can use and make a web interface that actually brings that. Then you can also have profile, a toolbox where people can come and work if you have a cloud web interface. So that is the idea. In this machine learning, we basically focus on putting together all algorithms. First, understand what parameters are there, how those parameters can be changed. If you change, in what direction you should change, we should also tell the user, because they are not the data scientists. As I told you, we are building this for non-data scientists. Only if we understand that algorithm better, if we understand the parameters, what we use, then only we can build this toolbox. Otherwise, it won't work. So when you study, understand them. Not the derivation. I'm not interested in derivation, but at least if I change these parameters, what happens? Why should I use these parameters? So you can go and see any machine learning libraries like TensorFlow or scikit-learn, all those things. There is good documentation. For each documentation, you can see what parameters the algorithm requires. Each parameter explanation will be there. Then you should understand for what purpose that parameter is there, what is the range of that parameter. Then you should also get some visualization techniques. How do you present that for the people? If you change this parameter, then your result also will decrease or increase like this performance. That is the expectation of the applied machine learning course. So as I told you, we will make bigger toolbox when we get into the data mining, all unsupervised learning. Even we may include recommendation systems also, but the data set may be in a different form which we require. We will think at that time. The focus is on building for forecasting or classification this machine learning toolbox for this with the good interface. So team up, I don't know, see how many of you are good with the web interface. I want you to team up four members into one to build this toolbox. So 4 means a triple IT, 23 is there. Good students will team up only 3 and remaining batches will have 4. Then Hemant, you should take that responsibility that it's once you form the group, you inform me. See that it's different talented students come together, not by just simply we are friends. That's why we are here as a group to do this project. Somebody who is interested in some web interface creation. I'm not saying that they should limit themselves to web interface, but they have some that skill, so they may help others to understand how we can create. Because data science is also web interface. How do you? Because finally, as I told you, we are going to talk to the business people. They don't understand your code. You should actually present it visually. So visually means interface should come. So how do you create those interfaces? So see that it's one of you are interested, have some knowledge of the how to create web interfaces. Some people have some good mathematics, statistics understand to do this. So one of the student is very good in writing Python code. All of you should gain these skills. When you team up, then one should cooperate with others so that your team will become strong and you can build a really, as I told you, very good toolbox, which I don't know, I'd say whether you appreciate or not, but I have seen many batches. But this is the toolbox which I have seen and be able to explain or give demo for even outside people's what my students can do that, it's and they're all really on a very good project with a very good client who worked on that. So I'm hoping that it's all of you, I should be able to present your toolbox to the industry people and say that it's we built a toolbox so that it's you don't need data scientists, you need toolbox. You need 1 or 2 people instead of 20 data scientists to write all these codes. So that is what my expectation out of this course and the next course, because this project will continue when we go to the next course. So all of you might have registered for applied machine learning course. So you may see that different modules there. So modules are basically taken from the Coursera course. Andrew Nagy, Professor Andrew Nagy. The course is taken by 3.4 million people, means 34 lakhs of people gone through that course. It's a very popular course. If you can crack that course, you got all basic machine learning, and he also written lots of material on machine learning, published even deep learning, all those things, published that book. You can search, I think freely available, that book. So if you are, I hope that all of you should register for that, as some of you did in big data course, where simultaneously you also got a certificate from Coursera. You can also get a certificate from Coursera. This project is specific to this applied machine learning. It is not there in the Coursera. This project we are going to do for the evaluation purpose. So whatever you do in Coursera, most of the assignments, they have answers available, GitHub, whatever that it's saying. So I am not going to evaluate you based on how you get a certificate or how you solve those assignments. I am going to evaluate you on the basis of the project, what you did, how you built this toolbox, how do you justify that that toolbox is doing a good job, how do you understand the algorithms, all those things. So your project is the 100% evaluation for this course. But still, to get here, to understand this, you need to complete all those assignments that will help you, quizzes, whatever is there in the course. Please go through, spend time before, let's say, starting this project. So that is one advice. So with this, if it is clear, we will get into the applied machine learning discussion. So I will leave it now for you. If you have any questions, another 5 minutes. And again, we will be back by 12 o'clock. I'll also give you 2-3 minutes break. If you have anything, then again, we will meet 12 o'clock. So it is open for you. If you have any questions or any comments on the topic modeling, what I have shown, or any other thing, It is open for you now.
So, sir, by when should we be able to complete this toolbox? I mean, with respect to the applied machine learning course.
The final evaluation will be at the end of the course. Means last Saturday or Friday of the course.
Okay.
So you will learn each week some algorithms, right?
Yes.
So those algorithms you understand first. Then you should be able to create a command line interface first. If a data set comes, then how this algorithm is applied for that without writing lots of code. Already you write that code, right?
Yes.
So if you give that as input, then it should perform that algorithm and it should give results. Then you understand better that what parameters I'm using in this algorithm. What are the best parameters? When you once you understand algorithm, then there many things are there to understand that algorithm. Then those also to be automated. The best parameters according to whatever code you write. Then, as I told you, if people want to try their parameters, changing their parameters, we should also give option. Because what happens most of the times, we take the random. So little bit variations will be there. As I've shown you, when the data took randomly, your results will change little bit, not much. As you have seen in the first, when we gave best algorithms, we got some 0.54 something highest. Then when we played with the parameters, we got 0.55. There is some randomness, even selecting the data, which for training, which for testing. So small changes will come. But anyway, we should also give option for the user to play with the parameters. So you should understand first algorithm and its parameters. How we perform. We should also show them visually. When you are changing your parameters, you may get this performance. So each week, 2-3 algorithms will come. At the end of I'm not focusing in this applied machine learning. All the algorithms, all supervised learning algorithms, you should add to your toolbox.
Right.
5 or 6 algorithms will come. If you include deep learning, then many algorithms will come. Another 3-4 will come. If there are no questions, we'll start again 12 o'clock. This link will be open like this only. If you want, you can have 5 minutes break. Okay. Welcome back. So one more announcement. It's even though if you are working as a team, each one of you should submit in the edX your project. So 4 submissions will come for one project. So your evaluation is based on how do you explain your project? What is your contribution? Those things. So you should also get thorough that it's all the aspects what you build in that project. So we'll get into the topics of the machine learning now. Okay, yeah, here it is. So I discussed largely this, the field of study that gives computers the ability to learn without being explicitly programmed. It's an older definition, informal definition. But in recently, CMU professor Tom Mitchell defined like this, what is machine learning? A computer program is said to learn from experience, E, with respect to some class of tasks, T, and performance measure P, if its performance at tasks in T as measured by P improves with experience E. So there are 3 words are used here. One is experience, second is performance measure, third is the task. So this is the same, similar to how humans learn. Humans will observe what's happening, what other people are doing. Then second, they will try to do the same way, the task, how other people are doing. And then after that, it's people will come to know that it's who is doing good, that is who is doing good or who is doing correctly. All those things are called performance measures. So experience means already observing other people, performing your task, then measuring that performance of how you perform, these 3. So whenever an algorithm, machine learning algorithm, machine learning means that algorithm should be able to get the experience, means as input. Then it should be able to perform a task. And we should also have a performance measure to measure whether the task is done as accurate or not, something like that. So we'll take some examples and see. Identifying pre-symptomatic COVID-19 patients. This is the task. So how do you identify pre-symptomatic COVID-19 patients? Then what experience we require for this? Observing symptoms of humans. So we will observe symptoms of large number of people. Then after some time, some people will come back and say that they got COVID. Then when they say they got COVID, then those profiles will take out and we will see how did they behave previous to confirmation of that COVID, previous 3 days, 4 days, pre-symptomatic, right? We are interested to see that what are the pre-symptomatic symptoms or symptoms before they are getting COVID. So that is what we are looking at, different files and we are getting some experience. Then based on that, okay, we will document them. Then if somebody is behaving like that, then we should be able to predict that you got all the pre-symptomatic things. So you may get very soon COVID. That is the task of predicting pre-symptomatic COVID-19 patients. These symptoms, whether leads to COVID or not, that we should be able to say. What is the experience as I explain continuously we will monitor 1 lakh people or 1 million people. In that 1 million people, all people may not get COVID, but some people may come with they got COVID. Then we will profile them separately. We'll go back and see in our history of collection of those symptoms, what were the specific symptoms to them when compared with other batch. So what actually led to them to get a COVID? With that experience, if a new symptoms we observe for a new person, then we should be able to predict that whether he is prone to get a COVID or not in next couple of days. What is performance measure? The performance measure is the accuracy of predicting pre-symptomatic COVID-19 patients. Then when you predict, then you will see that you have predicted 100 people will get COVID. Then if only 60 people got COVID with that symptoms, then your accuracy is 60. Something like that, we will have a measure that is called performance measure. Then another types of problems are there, segmenting humans based on their health parameters. So what is observance here? Observing symptoms of humans. So we will observe, means health records will take and observe their symptoms. The task of segmenting humans based on their health parameters. So some people are more prone to some types of diseases. So based on their health parameters, can we segment them? These people are more prone to get diabetics. These people are more to get cancerous, whatever that. So thus, that type of segmentation can we do on humans by looking at their health parameters. The experience is already who got affected those things, observing their symptoms, what symptoms they have shown before they got diabetic, they got cancer, whatever that is. Those records will take and observe what led to them or what is the symptoms they behaved before they got those diseases. Then task is segment before they get this. Then you can intervene and you can give medicines not to get a serious state. The performance measure is again the homogeneity. When you are making groups, this group is more prone to these type of whatever that is. You are putting them into groups. When you are putting them into groups, here it is not something you are not predicting. You are just grouping them. These people are having similar symptoms. These people are not having the same symptoms like other group. So what is performance measure? Here we should be able to say the homogeneity of the same group. If they are in the same group, they should have the same symptoms is more, and heterogeneity between humans fall into different groups is more. So when they belong to different groups, then there should be large, huge difference between their symptoms. That is the measure. When we see the clustering or segmentation, we'll study more. But basically, when you are grouping, you should get two measures. One is within the group, they should have all similarity or similar symptoms. Outside of the groups means people from two different groups, when you compare, their symptoms should vary largely. Then another thing is playing chess. In playing chess, each move will not say that whether you win or not. It only say that what is your probability of winning the game by that move. Then again, other person will move. Then also again you move. So each move will only tell you that it's how strong in the game. So unless you cannot predict that who will win, who cannot win, which step will win, because you need to take a sequence of steps there. So the experience playing many chess games. So what is experience means? We should be able to analyze many chess games and see that who won the games, then what moves they made, who lost the games, what moves they made. Then we should be able to understand that this move should lead to this. But anyway, that work is of the algorithm. You should be able to design an algorithm to learn from this experience to get a correct move to win the game. Then task of playing chess. So the task is you should play the chess to win. Then the performance is the probability of the program to win next game. So we will segregate into different things, this machine learning. Then you will understand that each one of these algorithms belongs to one of the domain of machine learning. The first thing is supervised learning. Supervised learning is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. In the supervised learning, we are given a data set and already know what our correct output should look like, having the idea that there is a relationship between the input and the output. So we know here what should be the output. In supervised learning, we know that it's what is the expected output. At least range we will know. So output should be this. Then usually in supervised learning, what happens? You will given a pair of things. In one of the things are called explanatory variables. Means they are the deciding thing to the result. Then other one is the result variable or response variable or dependent variable. All explanatory variables are also called independent variables. So those you don't have any control. Those will happen. If they happen, then you are going to predict what will happen for this human or whatever that. So then you also know that it's something like if you collect all the parameters, temperature, humidity, air pressure, then you may predict that tomorrow it may rain, it may not rain. So what is the prediction range? Just may rain, may not rain. If you want to predict how much rain it happens, that is a different problem. It's not a, there you need to say that it's 1 centimeter rain will happen, 2 centimeter rain will happen, 3 centimeters, 50 centimeters, like that, a range of real values. But you know that what should be the output, what are its boundaries. And you also have a clear thing of these are the explanatory variables or dependent variables. Based on these variables, I should be able to predict this dependent variable or response variable or target. So target variable, dependent variable, response variable, all are the same words. So in supervised learning, that advantage we have. So we know that what should be the output. So there is a master here. So that algorithm should be corrected based on whether you are getting correct output or not. If you are not getting correct output, then again you can go back and change your parameters so that it gets more accurate output. So that's why it is called supervisor, means you will supervise the learning based on the outcome. The algorithm will get a feedback from the outcome. Then again, it will change its parameters so that it adjusts its parameters and get a good result. That is called supervised learning. So in simple words, supervised learning, you are given a data set of different columns. 1 or 2 columns are called response variables or output or target variables. Remaining things are called explanatory variables or dependent variables. We should be able to get some mathematical equation based on these explanatory variables, how the response variable will change. So unsupervised learning is a type of machine learning that looks for previously undetected patterns in data set with no pre-existing labels. So there is no label or there is no target variable here, and with a minimum of human supervision. So not much supervision will happen here. So with minimum supervision may exist. Unsupervised learning, on the other hand, allows us to approach problems with little or no idea what our results should look like. Topic modeling is one such thing. We don't know that exactly how many topics we'll get. It depends on the, when you cluster, you are saying that 20, 30 you are putting. But if you want realistically put similar topics into same, dissimilar topics into different, without going through that data set, we will not come to know that see how many groups we can make. Whatever groups you make, you may have some performance to see that see how coherent those groups. But you don't have exactly, this is my output should come. It may come, all of the documents which you provided may belongs to only one topic, or they are into different topics. So that we don't know. And we don't compare that if somebody gets 3, then we cannot say that this is wrong or right. If somebody gets 4, still we need to analyze lot. Or it's in a e-commerce website, if they want to segment customers, so they may say that 4 different types of customers. They may say that it's male customers, female customers. Still it is valid. Nobody can say that it's this is not a correct. Or somebody may say that it's high spend customers, low spend customers. That is also good. So what type of result you will get, you can't know unless you run that. And there is nothing like wrong and right. That's why you cannot correct the result. Only you can analyze the result, how good result you got. So there is nothing like it is wrong, it is correct. So as I told you, in segmentation, in different dimensions, you can segment. That is called unsupervised learning, means we are not going to correct the result based on the output. Then other one is called reinforcement learning. Reinforcement learning, as I told you in chess, it is not something output you are looking always. At each step, you should be able to gauge how strong in the game you are by that step. Then again, whatever step you have put, then whatever step other person, continuously it should get feedback. That is called reinforcement learning. You should always take a situation, in that situation, whether you are strong or not. That performance we require. If you are strong, then it will say that, okay, take that step. If you take some step and finally you the game, let's say after computing the strength of your position in the game, if that becomes weak, then the signal should go. Then it should change those steps or coming steps. Something like continuously, you should optimize your chances there. I'll give you a good example when we discuss at length reinforcement learning. Reinforcement learning is an area of machine learning concerned with how software agents ought to take actions in an environment in order to maximize the notion of cumulative reward. Cumulative reward means strengthening your position in chess by taking that step. It is not win, because you will not come to know that it's unless the game is over, who will win, who will not win. With one step, it won't happen, the win. So here, if you see supervised learning, the data set will look like this. This ID you can forget. This income of the people, low, medium, low, whatever that, own home, whether they have own home or not. They are also listing their age. Then we need to predict whether if we give a loan to that person with these three properties, low income, having own home, and 30 years age, will it become a bad loan? Means will he pay back or default? So you have a clear-cut data set of columns and rows here. So these income, own home, age will become explanatory variables or independent variables that you cannot change. You are predicting based on that. You can predict that whether it is a bad loan or not. This is called supervised learning. When it comes to the unsupervised learning, this is also same supervised learning, but here you are predicting how much they spend based on these properties. So this is a classification, yes or no here, but here you are predicting how much with that income and having a own home at the age of 30, how much usually they spend. That is what we are going to predict. This is a number here. You're not predicting a class. So in supervised learning, you can predict a class or you can predict a range. Whenever you predict a range, that is called a regression problem. How much rain, whether it rains or not, that is classification. How much rain, it is a regression. Regression means it is you are getting a number, real number as a prediction. Classification means there are 3-4 classes or some n number of classes are there. You are predicting the given instance belongs to which class. So in supervised learning, each example is a pair consisting of an input object, typically a vector, and a desired output value, also called the supervisory signal. So a supervised learning algorithm analyzes the training data and produces an inferred function, which can be used for mapping new examples. The inferred function of that maps input variables to output variables y equal to fx. So if you see here, we should be able to get now this bad loan should be able to a function which can be explained through, that's why these are called explanatory variables. Can we explain that it's in these 3 parameters together will give this, but how do you? So of course, it's when you see the real machine learning algorithm, you will see that all these things will be converted into numbers. So some mathematical operations will be done. And finally, if this is y, this bad loan is a y, then these are called x0, x1, x2, x2. These are variables. Then y we will write something like x0 plus x1 plus x2. If that is greater than this, it will rain. If that is less than this, it will not rain. Some mathematical operations we perform based on this. Of course, you cannot perform your mathematical operation because these are not numbers, but we should convert them into numbers with a specific objective. That we will discuss later when we take an algorithm. So here we will get y as a value instead of a class. So we will not say that greater than, less than, whatever value you get, then we will say that value is this as a prediction. So we should get the response variable y as a function of response independent variables or explanatory variables. That is the whole essence of the supervised learning. An optimal scenario will allow for the algorithm to correctly determine the class labels for unseen instances. If a new instance comes, means today's parameters we got, we should be able to predict whether tomorrow it rains or not. So we will put today's parameters, all those things like air pressure, humidity, and temperature. We'll put, instead of x, those parameters, we'll compute this function, some value we'll get. Based on that value, can we say that how much rain will happen tomorrow or whether it rains or not tomorrow. So that we should be able to do. That function should perform correctly. That is what our goal. This requires the learning algorithm to generalize from the training data to unseen situations in a reasonable way. So we should be able to, we got only 3-4 examples. Now we are generalizing, means we are putting that as a relationship. So that by using this relationship, this is called generalization. See, here people may say that it's something, you got low, yes, 30, that's why you get yes, so whenever it is low. So this is a specific thing we are observing. If you get some hundreds of observations, so finally you should be able to give one function like y equal to fx. By using that function, we should be able to predict whether it becomes a bad loan or not. So that's why this is called, this f, the function is called generalization of all these observations. So we are trying to find a relationship between explanatory variables and the response variable. The same thing here. This is called x, all these things. This is called y. Y is a function of this x. This requires the learning algorithm to generalize from the training data to unseen situations in a reasonable way. So supervised learning problems are categorized into regression and classification problems. In a regression problem, we are trying to predict results within a continuous output. Continuous output means there is no gaps, means 0, 0.1, 0.2, any, whatever number you want, you can predict. Meaning that we are trying to map input variables to some continuous function. Regression predicts a real number. Range of output is infinite. In a classification problem, we are instead trying to predict results in a discrete output. Discrete means there are gaps between those. In other words, we are trying to map input variables into discrete categories. Here is a description on math is fun and on continuous and discrete data. Same problem, we can make a classification or regression. So we should be able to predict based on income and own home and education, what maybe the person is. That will become a regression problem if you are trying to predict his age. If you are trying to predict whether less than 40 or greater than 40, that becomes a classification problem. The same mathematical trick we use it. So here we are predicting some number. Instead of predicting a number, we fixed one number and we are looking whether it is less than or greater than. Less than is one class, greater than is other class. So same problems can be converted into regression or classification problems if required. Unsupervised learning, on the other hand, allows us to approach problems with little or no idea what our results should look like. We discussed this. We don't know exactly how many groups we'll get. What type of segmentation will happen? That also we don't know. We can derive structure from data where we don't necessarily know the effects of the variables. So even we don't know how these variables, because there is no response variable, first of all. So based on this response variable, we need to find a relationship, those things. Here, there is a group. Then you are segmenting them into different groups. On what basis you do that also you don't have idea. Whether if you get groups, then can you say that this is a good result, a bad result? That also you cannot say. But there are methods to see that it's, as I told you, if you are making groups, the one measure is within the same group, you should be able to find they are very similar items. Within the different groups, you should be able to say that they are different items. So we can derive this structure by clustering the data based on relationships among the variables in the data. So with unsupervised learning, there is no feedback based on the prediction results. That is, there is no teacher to correct you. That's why it is called unsupervised. Example, finding a method which automatically group a large collections of resumes into small that are similar with respect to different variables like skill set, education, experience, etc. So if you are given a million database of the resumes, can you segregate them based on their skill set, education, experience? So into different small groups. So what is reinforcement learning? What makes reinforcement learning different from other machine learning platforms or paradigms? There is no supervisor, only a reward signal is there. So at that point of time, you will get to know that it's how good, how reward that step you got. So feedback is delayed because after your step, you should also assess what is the output, how it is better or the worse than the earlier. So to compute that, it takes time. That's why feedback is delayed, not instantaneous. Time really matters because it is also, what is the current step is important than what is the previous 2 steps, 3 steps. So that's why the sequence of steps is also important. IID means independent, identically. Okay, we'll see that. Means independent and identically distributed, D means, okay. So this time really matters. Sequential non-IID data means each step, previous step is dependent. The present step is dependent on the previous step. In the supervised, unsupervised learning algorithms, we assume they are IIDs, means whatever instance we are taking, that instance is not dependent on other instances. That we will look at as an independent instant. That low, whatever is there, that one instance is not influenced by other instances. But here, each step is influenced by previous steps. That's why this is also one difference between other algorithms and reinforcement algorithms. Agent's actions affect the subsequent data it receives. So the algorithm is not final. It also should adjust. As I told you, feedback comes. Previous step strengthened your position or not, whether previous step got more rewards or not. Based on that, the agents is nothing but it is algorithm only. This agent's action is dependent on the previous steps and the result of them. Note IID means independent and identically distributed. That is, each random variable has the same probability distribution as the others, and all are mutually independent. They are dependent one on another. A reward RT is a scalar feedback signal here in that setup, indicates how well agent doing at step T. So it is time dependent. And at that time, this RT will tell how good the agent is doing. The agent's job is to maximize cumulative reward. This is also important reinforcement learning in automated cars. There, whatever steps you take after that step, whether you are good or bad, whether that is a right step or so, because the road, whatever that it's, if it gets close to accident, then it should find out whatever step you have taken that is not right. Again, it should take a different step every minute, every second. It should observe and correct the thing. That agent is nothing but a driver there. So the agent job is to maximize cumulative reward. Means you should save in auto driving. So reinforcement learning is based on the reward hypothesis. So first we should be able to say what is the reward to apply this reinforcement learning. All goals can be described by the maximization of expected cumulative reward. Example, manage an investment portfolio in stocks. So there is nothing like it's saying you will get this much or whatever that it's saying. You should be able to say that it's your investments are good and you are in a strong position, you get more profits. And it depends on day-to-day market and the steps what you take. So the agent will observe whether you are gaining or losing with that step. So if you are losing, then you change your investments. If you are gaining, then put more investments. So that is what the agents think. So in stock investment portfolio, if you want to manage, so you may need to apply reinforcement learning there based on the position you have in your investment. Goal: select actions to maximize total future rewards. So here goal is select those actions which will maximize your revenues in future. These algorithms will discuss tomorrow, this linear regression with one variable and multivariables. I have given broadly what is machine learning, what we do in this course, what is expected out of you. And I also suggested you to form groups of 4 members. One group will have less, it's okay. They may need to do a little bit extra work. And I asked Hemant to get those lists, right? 6 groups by the end of the day. And you can also go through the content, whatever is there in edX or in Open Coursera also. They're also explaining well. I'll also share this PPT. There are also some links here. I may also share this recording if you want to go through, but today we haven't discussed much. From tomorrow onwards. So what we discuss, if there are some derivations or anything, you can also go through these recording videos. And whatever doubts you have, Hemant, you can create a separate group for data science specialization in Slack. Then you can post your doubts. Then whenever I time, I write back or I will call you back in WhatsApp or Zoom. Whenever you post, you also write your number, WhatsApp number, if you want to be reached soon, so that it's according to my convenience. We can put a one-on-one to clear those doubts. Okay, I'll stop it here. Now there is another, we are already extended our time. But anyway, I'll stay back another 5 minutes if there are anything to discuss.
So what would be the timings of day-to-day classes? 11 to 12:30?
Yeah, whenever we have discussions, 11 to 12:30 only we will have. I'm sorry, last time it's a big data people should know that it's a, we were meeting only 11 o'clock, right? Daily.
Yes.
Yeah, so I thought it is apparent, but it got confused. But it's a, unless it is stated, the meeting will start 11 o'clock only daily. And unless you request, there is some other program, we cannot meet that day.
So do we have any stand-up meet or is it only 11 o'clock session?
I'm hoping all of you are grown up. I don't need any stand-up meeting. Now it is up to you. It's if you spend time on this subject and learn, then you'll stand better in the industry. So I'm not going to be after you. It's whether you woke up, whether you are turning up. No, I don't see many people are turning up their videos. Even I don't know. It's tomorrow the situation may come. You may ask some recommendation letter to do some higher studies. Then I may ask you again, who are you? Because it is not becoming familiar, right? You're talking without any video. Then even I may not recognize you, even in future also. The names, all those things. So you can be professional, at least it's when you are asking questions or something, you can turn on your video. Remaining times you can mute it. If you're not speaking, you can hide video. But it always becomes a good habit for you. If you're ready, camera ready. So whenever you are explaining or asking something, I can come to know that who's this person. Yeah, the simple thing is I am not going to after you. Now it is for you. There are 2 types of laws in nature. You might have heard. One is the cat law, one is the monkey law. Then the cat will carry its kids' cups with its mouth. It takes the responsibility to hold and shift from one place to other place. In monkey law, the kid should hold the monkey. Monkey never bothers about whether it hold tight or not, whether it fall or not. So that's why it is called, it's Marjala Markata Nyaya. So we are getting into the Markata Nyaya, means the monkey type of law. So how much you learn, that is up to you. The first part, Marjala Nyaya, whatever that it's carrying you, holding you, that part is done in the first year.
Hello, sir.
Yes.
Currently, from the JNTU, we need to submit names to Mohan sir.
That you need to discuss with Mohan. Mohan is
Yeah,
the
Arun Gar, I will take care of submissions, Arun Gar.
yeah.
Thank you, sir.
Okay. Thank you all. We'll meet again tomorrow.
Yeah, bye, Arun Gar.
Sir, I have a doubt.
I cannot hear you.
Sir, I have a small doubt. Can I stay back for a while?
Yeah. The class is officially over. The people who want to leave, they can leave. Yes.
So with the MSIT email, can we complete the Coursera course on machine learning and get a free certificate like we did on big data?
Yeah, but your evaluation is based on the project.
Right. But we can get the certificate, right, with the MSIT if we
Yes.
register with.
Yeah.
Okay.
Yeah, that is better, right? When you are doing the
Yes.
course, when you get as well as a certificate.
Right.
But like in big data, we are not going to give lots of grades based on that.
Right.
As I told you, everything is available there. So whatever you do, I don't have mechanism to check whether you did on your own, all those things. So this project will make me to understand whether you understand the algorithm, the parameters, how you are tuning them. So that's why your evaluation is based on the project.
Right.
And weekly, we will see your progress. This is a self-paced. Some people may add more algorithms in the first week. Some people may take more time. That is okay. But you should be able to justify that I did something in this week. Yes. Okay.